So you got this going on like this. Laser beam comes in, hits this. So what they're doing is they're increasing the angle of incidence, and then they're measuring that angle of refraction. Okay? So what do you notice about your angle of refraction relative to all the angles of reflection?
Less, smaller.
Always less, right? Your angles of incidence are always bigger than your angle of refraction. And they were nice, and they gave you the sine values. So if you would literally went in and you took the sine of those values. Now, what you're going to try and figure out is the slope of the line. Now, here's the deal. So you're talking about the index of refraction, so just think this through. You want to find the index of refraction. What does your index of refraction have to be bigger than? 1. Your index of refraction has to be bigger than 1. So right away, you want to graph values that produce a slope that is bigger than 1. Okay? So, in the name of time, if you graph the sine theta of incidence here and the sine theta of that refraction here, and it's very nice linear function, okay? And if you do that slope, and if you do change in y over change in x, you would get a slope of 1.4, okay? Now, so you have an index of refraction of 1.4. When that light enters that plastic, does the frequency get bigger or smaller? Does the wavelength get bigger or smaller? Does the velocity get bigger or smaller?
Velocity frequency doesn't change.
Velocity goes down.
How do you know the frequency doesn't change?
No color.
Red light up there, I had a red light laser. Whether it went through it or not, it was a red light laser. Because what determines the color? Frequency does. Okay, so frequency determines color. So if you go into looking at velocity equals wavelength times frequency. So if your frequency stays the same,
Wavelength has to also go down.
so if you decrease the velocity by increasing the index of refraction, what has to change? Wavelength has to get
What
shorter.
is that?
Okay, so the wavelength becomes smaller as it goes through that more optically dense medium. So you get that slope, you get 1.4. Now, on that back side, there's a back side to that. Basically, all it's asking you to do is find the slope. Now, when it gets to C, now it wants to confirm the results by measuring the critical angle. Okay, so the sine of that critical angle is going to equal n over air over n over the plastic. Okay, so then what's going to happen here is that now you have to shine that light through the curved side, make it bounce, and then go up. So what you could do then, if you could find that critical angle, you can use that as a second test to find that other index of refraction. If I were studying for this test, if it were me, I would make flashcards, concave, convex, lenses, mirrors. Okay? What produces upright, what produces inverted. You know you're going to have to draw a lot of ray diagrams. Go back to that very first assignment that you did, the second assignment that you did. Be fluent in your ray diagram. That is how the people you have to go.
Huh? It was one of those